Hello navigators, welcome back. In today's lecture, we are going to talk about another multi-phase solver that is present in OpenFOAM. First, I'll describe the scenario that what we want to solve. So far, using interFoam, we have solved a multi-phase flow between two immiscible liquids, for example, water and air. And then we also looked at potential foam and intraIsoFoam, in which the surface capturing was better than interFoam. And then we also saw a multi-phase flow in which two liquids are miscible. Now in this particular solver we are going to solve a different scenario in which we have three fluids. There could be more than three fluids as well, but we are going to consider three fluids to justify the scenario. Two of them are miscible, but both of them are not miscible with the third phase. So for example, there is a domain in which there is water and sludge. Both are going to mix with each other, but they are not going to mix with water. In that scenario, we can use this particular solver that we are going to discuss in this lecture. So let's get started. First, let me open the source code of this particular solver that we are going to discuss. Here, let's go to applications, and here inside interFoam we have interMixingFoam. The interFoam is a two-phase solver where it solves the interface by identifying the phases using the alpha parameter. In a similar way, you can do the same thing here, where there could be diffusion between two phases and there won't be any diffusion between the third phase. Let's see how the equation looks. This is the main solver. Here you'll see there is no difference in what an interFoam solver looks and what this looks like, but here the main change is in the alpha equation. In the alpha equation, first of all, here you have these equations that how you are going to handle the alpha. Clearly this is going to use the MULES algorithm, and then here you have extra this alpha 3 term. And so if we compare this with the alpha equation that we have here, let me go in the alpha equation. Here you'll see this is the alpha equation that is defined in the volume of fluid, and here you can see that only one alpha is there and the other one is just 1 minus that alpha. So this is alpha 1 and alpha 2 is 1 minus alpha 1. And here in the interMixingFoam, in this equation you have 2, alpha 2 and alpha 3. You can have at most only 3 fluids here. 2 of them can mix and the third one cannot. This can handle only 3 fluids or 3 phases only. And here you can see how it calculates the alpha values. Alpha 3 is 1 minus alpha 1 minus alpha 2. This is how alpha 3 is calculated. Alpha 2 is handled separately. Now this is the only difference. Otherwise, how the interface is handled, it is handled using the MULES solver. Let's try to implement this, set up a solver for this. We'll consider 3 phases. Let me copy the existing one. Let me take the water column because this is the one which takes alpha based interface tracking. We are going to take this and add this as intermix. Now let me edit this. Let's also clean this first. Now here we have only one phase right now. We'll add other 2 phases as well. We'll just copy this, rename this as alpha air and alpha sludge. Now for alpha air we are going to have this as air and then sludge here, and in the boundary conditions we'll have this in the sludge. For the top this is 0, that means no sludge, and we'll keep inlet with sludge only, but for water we won't have any inlet, so we'll remove this. Inlet will be just 0 gradient wall. We'll remove this and keep this here, and the top wall will be 0, that means no water there. And for air this will be little bit different. For air this will be 0 gradient and this will be 1. This is air. This is important. Here we want this wall to be initialized with air. Now these two will remain the same, and then let's go here. In the transport property we have to add one more phase, which is water, air, and the last one is sludge. Here the sequence matters because we have to define these sigma values as well. Let me go to the source code and show you. We'll have these sigma values as well. This is the alpha value. These are different for different phase, but these are the corresponding values, which is DC23 and DC32. This is a diffusion between 2, 3 and 3, 2. That means the second and third should be the phases which can diffuse. The first phase cannot be that. Similarly for the sigma parameter, we can see that in the create fields, the diffusion is going to take place between 2 and 3 only. For the surface tension, we should have a force that comes in the momentum equation. If we go here, we'll see that there should be a force due to surface tension which comes from the mixture. In the mixture, you'll have that particular surface tension defined. So we are not going to go there. So let's directly go here and see that how we define it in the transfer properties. Therefore, the first should be air always, and the second one can be water or sludge, and third one can be the other one. And here we'll also define the sludge, which will have slightly higher viscosity. I'll make this 5, and slightly higher density as well. I'll make this 1100, and we have a sigma value which is like this: sigma 1, 2 and sigma 1, 3. These are the surface tension coefficient between air and water and air and sludge, and there will be diffusion between air and sludge. This is how you define it, and then this will remain the same, and here the solver remains the same, because in the solver it does not matter whether it is alpha 1 or alpha 2, alpha 3, because it is going to solve for a generic alpha irrespective of whether it is 1, 2 or 3. And in the controlDict we have to write the solver name, which is interMixingFoam. I'll just copy this and paste it here. We have not defined this set fields because we should have one more field which is just sludge and just water, right? Let's do that. So first of all, we'll define everything as air and water and sludge. Air we want to be everywhere, and then water we want 0 everywhere, and sludge also 0 everywhere. Why do we want to do this? Because wherever we select these boxes, there we can set this as 1 and air as 0. Let's do that. We'll have this water column as 1, and then this as sludge to be 0 here, and then air also to be 0 here. Similarly here in the inlet, we want the water to be 0 and the sludge to be 1 and the air to be 0. Now we have these two boxes. This one is just the left inlet that we have used in various other previous lectures as well, and this one is the box that stays at t equal to 0 at some location, and then it falls down due to gravity. The gravity direction we have set along -z as before. Now we'll just run blockMesh first and then set fields. It has set the field, and now we'll run interMixingFoam. In the solver, alpha air is not found. Here we can use a shortcut here for all the alpha. Just solve using this, and now it will solve. There was some problem. Let's visualize what is it. So this is alpha water and this is alpha sludge is causing some problem. This is alpha air. Alpha sludge is 0 everywhere. That's what we wanted. Let's not use this inlet for now and use this as 0 gradient just to check. And then here in the setFieldsDict we can have another box which is sitting just at the top of this. It starts from this, from -0.2 to say 0.1. This is the sludge and there is no inlet. And now let's again do blockMesh and then set field and again run. Let me clean everything and then run. Looks like still there is some problem. Let's again see, we did a mistake here. So here this should be water, water, sludge, air, velocity. There is something coming from here still, so that is not okay. That means we have set something wrong here in the sludge. This is 0, in water this is 0, and in air this is 1, 0, 0. This is fine. In the pressure this should be fixed plus pressure, and velocity. Okay, here this was a problem. Here we can set this to no slip. Let's see the solver that was used before. I found the problem. Since there was diffusion as well, therefore we cannot use this MULES based solver directly. We have to use this one. This solver itself will take care of the MULES based algorithm part. Therefore, now if we run this now, it should not cause any problem. Now you can see it is running fine. Here you should note that this earlier for just interFoam we were using this, where we had a MULES character, and this character is used when there is no diffusion. But when we are doing interMixingFoam, then we should use this usual solver along with all these for the MULES solver. With this, if we now just look at the results, now you will see that these will mix as well with time. This is air, this is sludge. So let's look at the sludge as well. With the air you can also see that how it is leveling up with time. And let's see just water. There is no just water, it is a mix now. With this we can stop.
Thanks for watching, and if you like the content of our channel, then please like, comment, share and subscribe.